Hi, thanks very much, Christina. So this really is supposed to be interactive. It's sort of really basic. That's the point of this tutorial. So please interrupt if there are any questions. Is this working? Yeah, okay. So please interrupt with any questions, and we'll deal them as we go along rather than doing them all at the end. So, So what I'm going to talk about is what are the desirable characteristics of treatment antibodies, various display and non-display methods for getting antibodies, an overview, very brief, of phage, yeast, and ribosome, and then Jim will take over. I'll predominantly then concentrate on phage, and Jim will predominantly talk about yeast. Then there'll be techniques for generating antibody repertoires, a detailed presentation of phage display strengths, and then Jim will give the detailed presentation of yeast display. So this is a slide I just made yesterday, actually. Basically, 2009, we're up to $48 billion already for antibodies, FDA, of sales of antibody drugs. So already, the estimate for what was going to be around in 2015 has been will have been passed in 2010 already. So this is increasing at a phenomenal rate. There are 21, now it's up to 30 FDA-approved drugs, although monoclonal antibodies, although 4 have been withdrawn. So the number of antibodies in the clinic is really enormous. This is a slide that Henny prepared in 1999. It was updated a few years ago. This is basically the different sorts of technology. So hybridoma from mice, then chimeric, where the top portion, just the variable regions, were replaced. So you took mouse variable regions and put them onto a human backbone. This was introduced in start of the 80s. Humanization invented by Greg Winter, where you retained the mouse CDRs and placed them onto a human scaffold. Since then, there have been a whole bunch of different ways of essentially doing the same thing, many different names, and predominantly intellectual property avoiding mechanisms. So some people talk about veneering, but all of these different mechanisms ultimately have the same goal, which is to take the CDRs from a mouse and transplant them onto a human variable region that will provide you with the advantage of the human without the disadvantages of the mouse and the response against the mouse. Beginning of 1990, Greg Winter and Jim Marks, who's going to be talking next, were responsible for inventing phage antibodies. And this was the first time you could really get human antibodies relatively easily. 95, 96, mice where all the mouse genes had been knocked out and replaced with human genes in such a way that they were able to produce, just by immunization, human antibodies in response to anything. And then, since then, there have been no major technologies except yeast display, which was introduced at the beginning of around 2000. And what you can see here is that the whole antibody production has really got very, very busy. And in part, this is because any of these technologies takes about 15 years from when they're introduced to when they start producing drugs. And so what you can see is all these new drugs are coming out. Just to remind you, structure of an antibody. This is a full-size antibody here. We have the Fc domain here, which is the portion that provides effector functions, so binds to complement, binds to Fc receptors.